Okay, so we're going to move on and look at a little bit more in terms of shapes. In fact, this is not necessarily actually going to be any more than what you've already done. Okay, you've actually already looked at shapes in quite a lot of detail, but we're just going to revise it a little bit because I know you struggle with it a little bit at first. Okay, so there's two main areas that we look at in terms of shapes. There's lots of things you could be asked in terms of shapes, and we've kind of discussed in a little bit more detail things like triangles, looking at Pythagoras, and so on and so forth. But the two main things that you get asked generally in terms of shapes are the first one, which we're not going to spend a massive amount of time doing, okay, which is perimeter. And the second one we're actually often asked about, and we're going to spend a bit more time looking at today, is area, okay? Right, perimeter, I think a lot of people get bogged down in the idea that there's some kind of formula for it. And it can be, you can simplify it in many ways for different shapes, but generally it is just the distance around the outside of a shape, okay? And that just means basically adding all the different sides together. And obviously it depends on the shape, depending on what those different sides are. And if it's some kind of triangle, then it might involve some form of Pythagoras to get all the different lengths. But you've just basically got to piece together what you have in terms of the question, okay, the different sides that you may have, and work out if you need to find missing sides, and then work out how you do that. Okay, area generally does, though, involve different formulas. Okay, so area is the space inside a shape. And again, similar to perimeter, you might not be actually asked to find the perimeter. It might just say find the distance around the shape. In which case you've got to be aware that it is looking for area, okay? So if they ask the space inside a shape, okay, how much grass will be required for his garden, something like that. It might not necessarily actually area in terms of the word, but it might be kind of clear from the way that the question is worded that that's what they're looking for, okay? And you need to know about the shape, and you need to be able to obviously find the area based on what that shape is, okay? Right, but given it's the space inside a shape, what it generally revolves around is a kind of a much more standard shape, okay? Something that looks like this, okay? Just a tiny little square. And what we're looking for is we're looking for the space inside that. And we generally deal with 1 centimeter by 1 centimeter squares like this, okay? It might be different dimensions. It might be millimeters, it might be meters, but it's all 1 by 1. Okay, in which case what we say the area of that is 1 centimeter squared. And remember we put the little 2 kind of to up and to the right of the centimeter to indicate that we're basically finding area. If you see centimeters is written there, then it's in terms of dimensions, in terms of lengths. But when as soon as we write it as 1 centimeter squared, we're onto area. And there's a big difference between these two things, and you need to know that difference. But overall, what we're trying to do when we're dealing with areas, we're basically trying to find out how many of these little 1 centimeter squares we can fit inside a bigger shape. Okay, and we can do that by looking at the dimensions of something. If I show you just very quickly something like this, okay, this is going to be slightly smaller than that one would be. But what we've basically got here is we've got 6 of those little squares. Okay, 1, 2, 3, 4, 5, 6. Okay, and although it would be easier to just count these and see that this is just 6 centimeters squared, okay? If this shape was much, much, much bigger, we'd want an easier way of doing it. And what you can see hopefully here is that this distance, given that these are all 1 centimeter squared squares, this distance here would be 3 centimeters. Okay, so the length of the shape, the overall shape is 3 centimeters, and we can see that the breadth of the overall shape is hopefully just 2 centimeters. Okay, we've got 2 of these squares in line, so we've got 2 centimeters there. And if we take the 3 and the 2 and we multiply them together, we would get our 6 centimeters squared. My point being, if we had a 500 centimeter squared shape, we wouldn't want to have to add up all those different squares within that shape. We'd want a quicker way of doing it. And this is where the formula comes in, okay? And this brings us to our first formula for our first shape, okay? And you'll notice that this formula is actually used for both of these, okay? But if we start with this square, okay? And the square obviously has even sides, in which case it has a length L centimeters and pretty much a breadth L centimeters. They're both exactly the same. Then we can say that the area, okay, the space inside it, is length times by breadth. No matter what that length is and no matter what that breadth is, we can times them together, okay, and that will give us our area of that shape. Okay, so that's the formula, and you have to know that formula. That formula is not going to be given in your formula sheet. You have to know that formula off the top of your heads. Right, similarly, if we had a rectangle, okay, and that's going to be L centimeters by B centimeters, As I say, this one here, for if we're looking at the square, the b centimeters is exactly the same as the L because it's a square and because the sides are exactly the same. But what it leads us to here with a rectangle, if we're trying to find the area, in other words, the space inside, okay, it would still be length times breadth. It's fine. There's nothing wrong with having the exact same formula for these two. Okay, a lot of people don't use them. A lot of people try and mix it up and have two separate formulas, but it's just fine having length times by breadth. So the space inside that shape is just length times breadth. Right. The third shape I want to look at today is just a triangle. And this one's a little bit more tricky, and a lot of people just try and jump into this, okay, and think in terms of these formulas here. But these formulas work for squares and rectangles. They don't necessarily work for any other shapes. We do pretty much have, and we're looking for the area, we do pretty much have a length and a breadth. But what I'm going to call it, instead of that, is I'm going to call it a base, okay, because this will get your head around it a little bit more easily, and a height, okay. So the height is basically from the ground up in a straight line, and the base is across the bottom like that. The point being, if we were to turn this round, if we were to turn it round and we'd have something like this, okay, it would be a little bit more confusing. We obviously want to basically just change it around so that we're looking at these two dimensions here. This would be a base and this would be a height. They can swap round, it doesn't really matter too much which one's the base and height, but we don't want this one here. Okay, I'm not giving you this length here. I don't need to know that length there. It's not going to help me from my formula. It's these two that I need to know. In other words, it's basically the two that are actually at right angles to each other. It's very important to get your head around the fact that if we're trying to find the area of a triangle, is these two dimensions that we need. Right, and then what we want to do is we basically actually look, and we can see hopefully that you can relate this to this previous rectangle. And if you actually look carefully, if I was to draw a line here and a line here, what we basically do form is a rectangle, okay? And hopefully you can see from those dimensions, if we've got the breadth and the height here, if I was to multiply them together, then I would find the area of the rectangle. So the space including all of this orange shaded section. And that's not what I want. I just want the area of the, the triangle that's in purple, okay? So what I then have to do is basically divide it by 2. In other words, I have to half it, okay? And this brings us back to the initial formula, okay? So what we've basically got is we've got the area is going to be the base times by the height, but divided by 2. It's half of the base times the height. All we've got here of this overall rectangle, you can see if we took the base and the height and multiply them together, what we'd find is that overall rectangle. But for the triangle bit, the space in the kind of the bottom left, it is just half of that. So I need to take the base and height, times them together, and then divide it by 2, okay? Lots of different ways of writing this. Some people write it as a half base times height, okay? You don't need these multiplication signs in there, okay? So you can just write half base times height. You can write base times height and then divide it by 2, okay? You can write it in either any of these three, or you can actually use any of these three. It's entirely up to you. But the bottom line is, this is going to be the most important bit, this divided by 2, okay? However you write it, however you do it, you have to divide it by 2. You have to half the area of the kind of the outer rectangle, okay? Right, so I'll show you some examples now. Blue. All right, so we'll look at some examples. And the idea is that we're just going to find the area of each of these, okay? So find the area. Okay, we'll start with a square. And then we'll get a rectangle. And then I'll look at a triangle. Okay, right. So the idea of each of these is that we would generally have the dimensions. It might be a situation where it's a triangle, and we'll look at that later on, where we have to find a missing dimension. But generally, you can't actually find those missing dimensions, okay? So you'd pretty much be given them in each case. So let's just say this is 6 centimeters long here. And then on the rectangle, we've got an 8 centimeter by a 4 centimeter. And then for this one here, let's just go 3 meters, 4 meters, 5 meters. Okay, and I'll say that these are right angles to each other. Okay, so we're trying to find the area in each of these cases. So it is the space inside that shape that we're looking for. If we were looking for the perimeter, if it was some kind of question based on that, then we could still do it with each of these questions, but it would be a different answer. So we have to be aware of what we're actually looking for in each of these cases. Okay, so it says find the area, so that's what we're going to do. Okay. All right, so this is a square, and you'd be told probably something in the question, you'd be told it's a square, or you'd have these symbols here, basically telling you that all the sides are the same. But what it basically means is we've got 6 rows of 6 centimeters, okay? So in terms of the area, It's still just that formula, and length times breadth works. Just don't get carried away thinking length times breadth works for every single shape. It works for squares and it works for rectangles, okay? But it won't work for the triangle. But for these it works, and you've just got to realise that if it's 6 centimetres along the bottom, because it's a square, it will be 6 centimetres up the side here, in which case the area will be 6 times by 6. Right, 6 times by 6 is not 6 times by 2. It is not 6 plus 6. It is 6 times 6. So think in terms of your times tables. 6 6s are 36. Okay? Right, the stage that we're at, this wouldn't be the final answer. The final answer is not 36 because 36 is not enough of a description of what we're doing here. Okay? This is 36 centimetres, and it is very specifically centimetres squared. Okay? If I said centimetres, that would imply it's a dimension, it's a length. But this is not length that we're dealing with here, we're dealing with the area. And it's a different form of a dimension, okay? So it's basically 36 little centimetres squared. And what we've basically done is we've split this up into lots of little, 1, 2, 3, 4, 5, 6. Oh, I've done too many, okay. Basically 6 along the bottom there, and then there'd be 6 on the next layer, and then there'd be 6 on the next layer, and so on and so forth, until we filled that with centimetre squares, and there would be 36 of them. And that's the idea here, but we're basically doing it by a formula. We're making it simpler for ourselves. We're saying there's 6 centimetres along the bottom, there's 6 centimetres up the side, in which case there's 6 lots of 6, in which case there's 36 centimetres squared. Very similar with the rectangle. It's 8 centimetres along the bottom, so we've got basically 8 rows of 4, in which case it's length times breadth. It's 8 times 4, which is 32, and again, centimetres squared. Right, you'll start losing marks if you don't write the centimetres squared. So make sure you put it in, okay? Right, it gets a little bit more tricky when we get to the triangle, okay? The first thing you've got to do is identify that it is a triangle and then pick the right formula. This is a half times by base times by height, okay? Right, and I've done this, I've turned this round so you can see that it's slightly different because you've got 3 dimensions here, but the formula only uses 2. Okay, and again, you've got to be very, very careful of this. We've got a base and we've got height. That's all we need. We've got 3 different dimensions here, so we need to pick the right ones. So we've got to pick the base and the height. And this is what I mean. So imagine this is turned round, okay, and put properly on its side. So this is the 3 centimetres. This is the dimension that we need. This is kind of our base. And I'm going to flip it round, and this would be, therefore, my height, okay? And you can see that if I take the 3 and the 4 and multiply them together, okay, it will give me a different answer to if I took the 4 and the 5 or the 3 and the 5. Okay, so I have to be very careful with the ones I pick here. So it's going to be a half multiplied by 3 multiplied by 4. Okay, I know a lot of you get confused at this stage, but you could do this in any order. You could do a half of 3 if you wanted to, okay, which is 1.5, and then times that by 4. 1.5 times by 4 is just 6. Okay, you've got a full 4 and you've got half of 1. That's a bit more difficult because it's got decimals. So try something different. Do a half of the 4. Half of 4 is 6. Then, half of 4 is 2, and then times it by the 3. That gives us the 6 that we had before. Or you could just do 3 times 4 and then half your answer. 3 times 4 is 12, half of that is 6. Whichever way you choose to do it, the answer is 6. And then you've got to be careful here. This one is meters squared. Okay, it's meters squared because we started the question. The question itself is in meters. So the answer is in meters squared. Don't worry too much about the units. The only thing you really need to be aware of is if the units in the question are different. Okay, I could have written this as 300 centimeters and 4 meters. If they're different units, you have to change them so that they are the same unit overall. Okay, right, so that should get you started with area. Just be very, very careful what the shape is and pick the correct formula for that shape. If it asks for area, then it's one of these formulas. If it asks for perimeter, then it's adding up the sides. Okay, for example, if I look to this first one, okay, if I want the distance around the shape, okay, it's basically that plus that plus that plus that. 6 plus 6 plus 6 plus 6. Okay, which is 24. It's 6 times by 4, so there could be a formula there, okay, but it just ends up getting a bit more confusing. Similar with this one, if I wanted the perimeter, it would be all of these sides added together. 8 plus 4 plus 8 plus 4, okay, and then the last one, 3 plus 4 plus 5. But that's a different question. This one specifically asks for the area, okay, so answer the question that's given to you.